Hello students, today is the last experiment which we'll be doing, that is digital multiplexer. Now what is a multiplexer? A multiplexer is a switch. This is the circuit diagram for an analog switch. So we'll see that there are 4 inputs: TV, let's say this is the computer, amplifier and your PlayStation. This is connected to a switch which will go the output to a speaker set. So we can turn the switch or keep the switch on the TV side, then the audio output of TV will play on the speakers. Now if we change the switch to computer side and play some music, then we'll have the connection for the speakers from the computer or from the amplifier. So we have to change the switch to the 3rd position or to the 4th position for the PlayStation to get the output or audio output to the speakers. So this switch is like the address. An address like a digital address could be 00. The next one could be 01, like the address. For the analog switch we have to change the position of the switch, but for a digital multiplexer we need to give the addresses. So if we have 4 ways, 1, 2, 3 and 4, the digital address could be 00, 01, 10 and 11. So now let's look at the real experiment for digital multiplexer. This is a circuit diagram which is drawn over here. You will see that the address is given by the NOT gates, that is here and here. A and B will give you 4 different combinations: 00, 01, 10 and 11. And the AND gates, are 3 input AND gates. You will see 3 inputs. So this first denote is the first input. The next input is D1, D2 and D3. So if we want the input from D0 to reach at the output, we need to give the address A and B. So A is 0, B is 0. A bar and B bar are given to the first AND gate, and therefore the first AND gate will be enabled and will get output D0. So if we want D1 to reach at the output, we have to give 0 and 1. The third one will be D2. We have to give the address 1 and 0. And the fourth one, 1 and 1, which will reach D3 at the output. So the truth table, A and B, 4 different combinations: D0, D1, D2, D3 and the outputs. So we have to verify. Now our 3 input AND gates, we have in a single IC only 3 gates. So I've taken over here two gates. One gate, IC1, IC1 is one 3 input AND gate 7411, and the other is the next IC gate. So I've made the connections already. These are the connections. Let's see, D0, D1, D2, D3 and the addresses are given here. So this is the connection which I have made. The first IC is a NOT gate. Then we have 7411, which is the next IC. The third one is also 7411. So I've used 3 input NOT gates, NAND gates, and I have the OR gate here. So I already made the connections. I've given VCC in the above top line, which is here, and ground, which I've given here down. And these 2 inputs are A and B inputs. This is the address to choose. This is D0. Then the next Y is D1. D1 is here, D2 and D3. Okay, so let's verify the output. So I'm going to switch on 5 volts. I'm giving A and B as 0 0, so I'm giving it to the ground line. And D0, which is this point, if I give it to 1, the output the LED remains 1. If I give D0 to the ground, the LED goes off. So I am verified. If A is 0, B is 0, D0 goes to the output. D0 equal to 1, the output lights up. D0 equal to 0, the output goes off. So I verified the first condition. The next condition is for using the input D1. So for D1 it is 1 and 0. So I'm putting this line to VCC, the address, so it is 1 and 0, 1 and 0. I'm going to use D1. If it is 1, the LED is on. If it is 0, the LED goes off. So I have verified when the address is 1 and 0 that D1 goes to the output. Then the third combination is 0 and 1. So I'm putting the A and B as 0 and 1, and taking out D2. D2 equal to 1, the LED is on. D2 equal to 0, the LED goes off. So I verified that when the address is 0 and 1, that D2 reaches at the output. And for the last condition, I have A and B both are 1. So I'm removing the wire and I'm putting it over here for the VCC. And D3, if you give it 1, the LED lights up. If you give it 0, the LED goes off. So I have verified that giving addresses to A and B 0 0, that D0 reaches the output. And if I give 0 and 1, then D1 reaches the output. And if I give 1 and 0, D3 reaches at the output. And D3, when the address is 1 and 1, that D3 will reach the output. So the circuit behaves like a digital switch. By giving addresses 0 0 or 0 1, 1 0 or 1 1, I can make any of the inputs over here to reach at the output.